Unit 1 Review, question number 26. In 2017, the population of Rexburg, Idaho was 28,337 people. The population was expected to grow at a rate of about 1.21% per year. Based on these numbers, what would we predict the population of Rexburg will be in the year 2021? The first thing I did is come over to Excel, and I'm going to show two different ways of how to find this. The first one will be an iteration using the capabilities of Excel. The other one will be using an equation, and you can do that in Excel or on a calculator. So the first thing I'm going to do is say so I've written out all of our information, and the population is 28,337. Since I've already written that here and I don't want to type it again, and it helps prevent typos, I'm just going to go ahead and do what's a cell reference just for this first year, noting it right here. Now the next year we were told is an increase or grow at a rate of 1.21%. In the previous videos we talked about more than or an increase. To do that, that means that I have 100% of the total plus an additional whatever the growth is. In this case, 1.21%. Changing that to a decimal is 0.0121, and that's what our increase will be. So we'll take that number, 1.0121, and multiply it by the previous year. And we will do that for 4 years so that we get the total population in 2021. So here we'll do equals, and 1.0121, the 100% of the original population plus the additional increase of 1.21%, and multiply that by the previous year, which will give us the population in 2018. Now because I've used Excel and I've done cell referencing, I can click this bottom crosshairs and pull, and you'll see that it duplicates that equation. So if I double click in here, it'll show we have the 100% and the 1.21% increase times the previous year's population. And when I click and drag, it took the cell reference from above and it dragged it down with me. To get out of this, press Enter. Don't click anywhere else or it'll reference something else. And I can do the same thing again here, and you'll notice again it's dragging that cell reference above. So this will be our total. You could do this by hand and multiply that each time so that you have multiplied it after 4 years, and you will hopefully get the exact same here. But there's so many opportunities for typos or just typing it into your calculator incorrectly that this way is very, very fast, very efficient, and helps prevent mistakes. The other option is an equation if you would like to write this out, and we'll do equals. Again, we still have the 100% and the additional 1.21% and the original 337. So I'm just going to reference the original, the total, and multiply it by our 1.0121. Now that's the increase per year. But because I'm increasing this per year, instead of doing it 4 different times, when I multiply something additionally by itself, it ends up giving us an exponent. So that's saying that I'm going to go more times of multiplying. So I'm going to raise this to the 4 so that I don't have to do this 4 times out. It's a little faster, but some people might be a little more hesitant to remember that. One way to remember that when I multiply several things at a time that I end up with an exponent is to remember that x times x gives me x squared. And so that shows that I'm multiplying repeatedly. Multiplication is addition repeatedly. And so this is just one way to help you remember that that gives you the exponent. And so in this case, I went out 4 years. Again, just like we did in the iteration method, I started with the original population. I multiply it to the more than 100%, and then we have the growth. So we can think in our mind it's the same thing as the previous examples of when we hear the words more than. And then the 4 out here just means that I'm doing it 4 times, and so it was faster that way. All right, so that is question number 26. Let's go ahead and round this to the nearest whole person. So we have 29,734 people, and we can move to the next problem.